Hello, greetings to you all once again, and I'm excited to come here once again with the calculus tutorials. Okay, so this session we are just talking about part 2 of what I uploaded yesterday. Okay. Yesterday, our goal, right, was to talk about the product rule, right? Then we also target the quotient rule. Then we talk about the chain rule, right? The chain rule or function of a function. Function of a function, right? Function of a function. Then we also have the successive differentiation. This was the goal in our previous video, but because the video was becoming so long, right, I was able to tackle the product rule and the quotient rule. So these were done in the previous videos. So I will entreat you to watch it if you don't understand the product rule and the quotient rule. Although I'll solve some questions here as well. So our goal is to talk about the chain rule and the successive differentiation. So the part 2 of the video is the chain rule, right, and the successive differentiation. So these two was tackled in part 1, right. I'll leave the link in the description. So please try as much as possible to subscribe to my channel, right. I can see that a lot of people are watching the video, but only if you are subscribing. Try to subscribe to my channel, and at the end, it's a form to say you are grateful. Okay. So let's move on. We are going to talk about the chain rule. Or we can say function of a function. In the book that I sent to you, it's termed as function of a function. The book that I sent to you, that you should use it in solving the calculus. So it's termed as function of a function. Do you get it? So we're going to talk about that one today. Assuming I have a function y equal to u of v of x, right? Yes. So I can also term it as y equal to v into brackets what u of x. Any of them. Do you get it? Yes. So there's a function in a function. So we have the vx here, which is located in the function u of x. Do you get it? So here I'm going to just state the the formula straight away. Nobody's going to ask you to prove this formula. Okay, so I'll state the formula straight away. Then you will solve some questions for you to get the concept very well. So with this kind of function, if I want to find the y on the x, the reason why it's called chain rule, right? The formula is stated as the y on the u multiplied by what? The u on the x. So you can see that they are in chain. Okay. So the u and the first derivative is linking what? The second derivative. That's the reason why we call it the chain rule. I can cancel out the u and I'll still get what? The y on the x. If I should simplify these two derivatives, right? If I just simplify it, I'm going to get the y on the x. I don't want to prove it because it's going to be a very long procedure. At the end, the video is going to be long. So nobody is going to ask you to prove it. You just need to have the formula in mind and you'll be fine. Are you okay? So anytime you are given a question, always take note that the chain rule formula is given as dy on dx equal to what? Dy over du multiplied by what? Du over dx. Okay. So let's typically solve an example. But please, before we even solve an example here, I want you to have the special differentiation in your mind. The special differentiation, I want you to have it in your mind. In the previous video, I stated it there, and in the comments, someone was saying that I've made a mistake, but I saw it that I corrected a mistake. So I'm going to write them here again. If you watch the video continuously, you see that the mistake has been corrected in the video, in that same video. So there was no error in it. But I want to repeat them here once again so that you will not forget them. It's very, very important because it will help you in your calculations, almost all the differentiation, especially when you are finding a differentiation of implicit functions, something like that. So assuming I have y or a function f of x, right? Its differentiation, which is dy on the x or f prime of x, is given at the other side. So if I have axn, right, then its differentiation is given as what? An x n minus 1. Please take note of it. It's very, very important. It's a general formula. So if I have sine ax, right, then its differentiation is going to be a cos what? A cos ax, right? If I have, how do you call it? Cos ax, right, it's going to be negative a sine what? Sine ax. Take note of it. Like, this was where the person was pointing out the mistake, but he just watched up to 4 and 30 minutes. But if you move to, let's say, 4 to 15 minutes, you see that I corrected the mistake there. So there was no mistake over there. Take notes very well and make sure that you have this in mind. Okay, so that's it. And if I also have ax, then it's going to be what? ax, right? That is the a multiplied by e exponent, like ax. Then if I have then ax, the final answer is going to be 1 on x. So you should take notes. We can use the chain rule in proving this, some of them. Okay. This, like this, I can use the chain rule to prove it. This side, I can use the chain rule to prove it. I can use the chain rule in proving the then ax. Okay. So you are going to solve question under 8 and you understand very well. So let's move on. Let's move on with the chain rule. Please, I'm stressing on it once again. There are certain questions in calculus. You need to solve them in a short way. If you try to use step by step, you will not finish when the time is up. So try as much as possible to know this one off head, and it will really help you. You get it? Yes. So let's go back to our chain rule. We've made it clear that if I'm differentiating, the chain rule, dy on the x, is also giving us dy on the u multiplied by what? The u on the x. Okay. So let's take a typical example. Assuming I have, assuming I have y. So that's just by the way. So sorry. So assuming I have, let's say, y equal to what? 3 cos 5x squared plus 2. Right. So this is the question. They said find dy on the x of, right. So assuming I have this question, I'll say that y equal to what? 3 cos 5x squared plus u, right? So here we can see that this 5x, let me use a different thing. So this 5x squared plus 2 is a function, right? And it's in a bigger function, which is 3 cos, what is inside here? So this side 2 is also a function. So we have a function in a function. Okay, so we can let the function which is inside here be represented with, let's say, u. Okay, so we can say that let u be equal to what? or u of x. Okay. Let u of x be equal to what? 5x squared plus 2. Okay. So we are going to let u of s be equal to 5x squared plus 2. So what will be du on the x? What is it going to be? So du on the s is going to be what? 2 times 5, which is 10x, right, plus 0. So 10x plus 0. If you are struggling to do this simple differentiation, it means you've not watched my first video. Try as much as possible to watch it, and you understand why we had the 10x. Okay. So we've simplified this one. So if we say that u, right, of x is given by 5x squared plus 2, then we can say y is equal to what? 3 cos u, right? 3 cos u of x, any of them. So 3 cos u. We have let u represent this function. So we found the u over the x. So in that case, we will say that y is equal to what? 3 cos u. So here, finding the y on the u is very simple. So what is the y on the u? The y on the u is simply going to be negative 3 sine u. I believe you agree. Yes, negative 3 sine u. This one, if you are struggling with it, it means that you don't understand the shortcut here. That is the main reason why I told you to learn the shortcuts. Okay, so once you understand the shortcut, it becomes very easy to differentiate trigonometries. So here, we have seen that the y over the u is equal to what? Negative 3 sine u. So, now that we've been able to find the u and the u over the x and the y on the u, we can say that the y on the x is given by what? The y on the u multiplied by what? The u on what? On the x. So you can see that it's the shortest form. It's very simple. It is called chain rule because they are linking. The u is linking them. Okay. Yes. So at this point, we can just substitute. The y on the u was given as what? Negative 3 sine u multiplied by, what was the u on the x? This was given by 10x. So multiply by what? 10x. So here we can simplify. We can say that it's given by negative 10, 3 is 30, right? Negative 30x sine u. Okay. Yes. But what was u? But u was given as what? U was given as 5x squared plus 2. So u was given as 5x squared plus what? Plus 2. So we can just substitute it into it. Then it will give us the y on the x. So the y on the x can be given as negative 30x sine what? Sine 5x squared plus 2. And that gives the final answer. Yes, it's very, very simple. This was my favorite differentiation when I was in high school. So I really loved this kind of differentiation, right? It's so easy. There's no confusion. I think this was the first differentiation that I understood, right? Before going to senior high school too. I personally learned this on my own. So I really understood it. Yes. So it's very wonderful. Right? Let's have another question. Assuming I have, how do you call it? Assuming I have y equal to 4t cubed minus 3t, right? Or exponent 6, right? I have this question and I'm asked to find the y on the x, right, of, do you get it? Or find y prime of this. So assuming I have this question, what do you think it will be? So the bigger function is the whole of it. This is the bigger function, right? And we have a smaller function in it, which is the 4t cubed minus 3t. Right. So that's it. So you are going to let me solve the solution. You are going to let u of x or u of t, this time is t rather not x. So you are going to let u of t be equal to what? 4t cubed minus 3t. So what to be du on the t? Du on the t is simply going to be what? 4 times 3, which is 12t cubed square. Yes. So it's going to be 12t square minus 3. Again, if you are struggling to understand this, please watch my first video or the second video. The first video was on limits. The second video was talking about this special differentiation. So please watch it and you understand very well. So now we have du on the t, so we go to this one, right? So what is going to be our y now? So our y will be equal to what? U exponent 6, because we made it clear that the u of t is given by what? 4t squared minus 3t, right? Take note, they are the same. It's u, right? It's the same thing, so don't be confused with this. Are you okay? The reason why I don't want to bring the t here is because I don't want to end up confusing you people. That's the reason why I don't bring the t. Are you okay? Else you become confused and at the end you are going to find it difficult. So the u of t and the u, they are the same thing. Take note of it. So y equal to what? U into bracket t, u exponent 6. Are you okay? So once we have this one, so what will be dy on du? This is going to be what? 6u5. I'm not expecting you to say why did you get this, because I believe that you have been following me and you understand these concepts. So now that we have the y on the u to be 6u6, then 6u5 rather, sorry. So then we can see that the y on the x, right, is equal to what? The y on the u multiplied by what? The u on the x. So what was the y on the u? The y on the u is simply 6u exponent 5 times what is the u on the t? Why do I keep on interchanging the x and the t? I'm so sorry. So it's t, right? Because the independent source is t, right? Independent source is t. So it's not dy on the x. So it's dy on the t. You get it? Yes. So 6u exponent 5 multiply by what? Multiply by, how do you call it? What is the u on the t? Which is 12t squared minus 3. We are going to get 12t squared minus 3. Yes. So that's it. So in this case, we can simplify, right? So if you substitute it, what do we have? What was the u? U was giving us what? U was giving us 4t cubed minus 3t. That was u. So we will get 6 into brackets 4t cubed minus 3t, all multiplied by what? 12t squared minus 3. And I think you can end here. So the y on the t is giving us this 6 multiplied by 4t cubed minus 3t and multiplied by 12t squared minus 3. So this is the final answer. Please take notes. If you are struggling to understand this, visit it again and you get the concept. Okay. So let's also talk about the length. Assuming, let me create my own question. So it said find, right, the y on the x of y equal to what? Length 4x plus 3. Do you get it? Yes. So what do you think the answer is going to be? Right. The answer will simply be, you differentiate this one outside. Then you differentiate this one and bring the value outside. Right. Then we write this one 1 over it. But let's solve it. Let's solve it. I don't confuse you. Let's solve it using the chain rule. Right. So let's solve it using the chain rule. The solution. Right. So let u of x or v of x, any of them, u of x will equal to what? 4x plus 3. Right. So du on the x will be giving us what? Will be giving us 4. Yes. So that's it. So if u of x is giving us 4x plus 3, then y will be equal to what? Y will be equal to ln u, because it's the same as the 4x plus 3. So in this case, dy on the x, dy on the u, dy on the u will be giving us what? 1 on what? On u. Because we stated in the rules that, we stated it clearly over here that ln ax is equal to what? 1 on x. So that's it here. That's the reason why we are saying that ln u is giving us 1 on u. Okay. So now that we've gotten dy du and we've also gotten du dx, we can say that dy on the x is giving us what? Dy on the u multiplied by what? Du on what? On the x. So now what do we have? Dy on the u is giving us 1 on what? On u multiplied by du on the x, right, is giving us 4. So u was giving us, but u was giving us what? 4x plus 3. So if you substitute, you will say that dy on the x is equal to what? Dy on the x is equal to 1 on what? On 4x plus 3 multiplied by what? 4. And this gives 4 into brackets 1 on what? On 4x plus 3. So that's the final answer. You get it? So what I was trying to tell you is that you don't need to pass through, if you get some simple question like this, you don't need to pass through this step, especially if you need to do more differentiation. For instance, if I have the ln 4x plus 3, right? What I was trying to tell you is that if I want to differentiate this, one, right, I'll differentiate the one inside and bring it out. So if I should differentiate the one inside and bring it out, what do I get? I'm going to get 4x. Oh, 4. Sorry. If I should differentiate the one inside, I'm going to get 4. Then I'll multiply by the ln of this is giving us 1 over what? 4x plus 3. You need to know these ones, so that when you are solving a lot of differentiation, you don't need to pass through this long step, the chain rule. At times, you do the chain rule in your mind and quickly get the results. Do you get it? So let's try once without the chain rule. For instance, if I have cos 3x squared plus 4x, right, minus 3. Do you get it? What I do is that I differentiate what is inside here. So if I differentiate, what do I get? I'm finding d over the x of this. Right? I'm differentiating. So if I should differentiate what is here, what do I get? I'm going to get what? 6x plus 4. Yes. So that's it. I'm going to get 6x plus 4. Then I'll differentiate the whole thing again. So if I should differentiate the cos, what do I get? Negative sine what? Negative sine 3x squared plus 4x minus 3. You get it? Then after I'll multiply. I'll bring the negative out. So I'm going to get negative 6x plus 4 sine what? Sine 3x squared, right? So this is going to be multiplied. Are you okay? Or it's better to leave it like this, in order not to confuse yourself. Right? Let's leave it like this. So this is what the differentiation of this whole thing is. So differentiation of all this ends up becoming differentiating the one outside, right? Then you differentiate the one inside. Are you okay? You get it? Yes. So let's solve this one using the chain rule, and you understand what I'm talking about. So just keep note of the answer. Are you okay? So take note of the answer, and let's solve this one using the chain rule. So assuming I have y equal to what? Cos 3x squared plus 4x minus 3, right? So if I should simplify this one, I'll say that we should let u be equal to what? U be equal to 3x squared plus 4x minus 3, right? So du on the x, what will be du on the x? It's going to give us 6x, right? 6x plus what? Plus 4. So I will say that y equal to what? Cos u, right? Y is equal to cos u. So since y is equal to cos u, then dy on du, right, will be given as what? Will be given as negative sine u. So in that case, dy on du is given as dy on the x, right, is given as dy on du multiplied by what? Du on what? On dx. So what is dy on du? Dy on du is negative what? Sine u, right? Multiply by what? Multiply by du on the x, which is given as what? 6x plus 4. So in that case, dy on the x, right, will be given as negative 6x plus 4 multiplied by what? Sine of u, right? So what do we have now? We are going to get negative 6x plus 4 sine, and what was u? U was given as 3x squared plus 4x minus 3. So you see that it's the same value there, right? This one, the negative can come out, which is negative 6x plus 4, right? All multiplied by what? Sine 3x squared plus 4x minus 3. You get it? So it's the same thing as we've seen over here. It's practice. Keep on practicing. Practice makes man perfect. So at times, right, there are certain questions. You don't need to show all these things. If you show all these things, you are wasting your time. You just use your brain and you simplify it as I did here. Okay. So keep on practicing calculus. Don't think you've understood it to the point that you will stop. Keep on practicing calculus. Okay. And when it gets to the exam time, you'll be able to pass. If you don't want calculus in the near future, just pass your exams and move on. But it's better to understand it so that in the near future you can also teach people. Okay. So the last question that I'll solve before we move to the successive differentiation is to find dy on the x of what? Of sec square x of y equal to sec square s, right? So this one is, I think this one is in your handouts, but they didn't prove it. You can choose to memorize it. You can choose to understand why we had this one. You can apply the chain rule in solving it. Let's simplify it. So we know that y equal to what? Sec square what? Square x right? We can further simplify this. Y is the same as sec x all squared. Last time I told you in my previous video, I told you that cos square x is the same as what? Cos x all squared. So it's the same thing, no difference. Okay. But we also know that sec x is the same as 1 on what? On cos x. So in that case, y can be written as 1 over cos x all squared. You agree? Yes. And if you want to make the cos x as the numerator, right, we can say that y equal to cos 1 exponent or cos exponent negative 1 on what? Square. We get it. And this is the same as y equal to what? Cos x minus square. Or better still, this one is you are going to get the same thing. You have 1 on what? Cos squared x. You can see that it's 1 squared over cos squared x. It's the same thing. And I'll move on to say that it's the same as what? Cos x or exponent minus 2. So you see I've arrived at the same part. This is a very long process. When you get something like this, you don't need to pass through on if you know it off head. If you really know it off head and they give you such a question, right? You don't need to pass through all these steps. I'll just explain it to you why we had that. Probably maybe if I should write it, someone will say, why you didn't get the cos x or exponent negative 2. You get it. It's going to be something that people will be complaining about, that maybe you don't understand what I'm teaching. I don't want a situation whereby someone will come and say, why did you get this straight away? That's the reason why I was explaining to you why we had that one. So if, let's say, I'm supposed to solve it, I don't need to write all those ones. All that I need to do is to say that y equals to what? Cos x or exponent what? Minus 2. And I've proved to you why y is equal to cos x or exponent negative 2. If you are still asking why I had cos x or exponent negative 2, then reverse the video small and you understand what I'm talking about. Now that we've been able to arrive at this, right, we can say that if you let u be equal to what? Cos x. So if u is cos x, there ought to be du on the x. U on the x will be given as what? Minus sine what? Sine x. Okay. So now, if u is truly cos x, then y will be what? U exponent what? Minus 2. Right? So in that case, ought to be the y on what? On the x. The y on the u, sorry. The y on the u will be given as minus 2u. This is minus 2 minus 1, right? This gives us minus 3. Okay. And this is the same as minus 2 on what? On u cube. Okay. Because u minus 3 is the same as 1 on what? On u cube. We should take note of it. Okay. So at this point, now that we've been able to find the u, the y on the u, and the u on the x, we can clearly say that the y on the x is given as what? The y on the u multiplied by what? The u on what? On the x. You get it? So the y on the u was negative 2 on what? On u cube multiplied by what? The u on the x, which was given as minus sine x. Minus sine x, right? So at this point, I can further simplify this one. The negative is going to be positive. So I'm going to get 2 sine x all on what? On u cube. What was u? U was given as what? Cos x. Okay. So u is cos x. So in that case, we will say that 2 sine x all divided by what? All divided by cos cube x. We can still simplify because we can get some direct function in that. So Here we will say that 2 sine x all divided by what? Cos x multiplied by what? Cos squared x. Yes. So here I'm saying that if I have cos x, cos cube x, I can just use only one cos x multiplied by cos square x. Because of this is the same as the cos cube. Right? So at this point, you can clearly see something. We have 2 multiplied by what? Sine x all divided by cos x multiplied by 1 on what? On cos squared x. Okay. So cos squared x can stand on this one. Sine x on cos x can stand here. And the 2 can also stand by itself. So at this point, what do we have? Sine x cos x is the same as tan x. We can get 2 tan x multiplied by what? And this is the same as sec squared x. Are you okay? So we are able to prove that one here. This one, we made it clear that is the same as 1 or on cos squared x. So in that case, the 1 on cos squared x is the same as sec squared x. Because if I should further explain for someone to understand it very well, it's the same as cos x all squared, right? And 1 on cos x is the same as what? Sec x. So sec x all squared, right? And sec x all squared is given as sec squared s. So that's the best explanation that I'm going to do. I explain myself in several ways so that if someone is struggling, the person will better understand it. So at this point, we've been able to prove the y on the x of sec x squared. Sec squared x. So sec squared s is given as 2 tan x. Sec squared x. You take notes. It's in your handout. When you open your handout, we are talking about differentiation. We've written some of these functions there. So you can use the chain rule to prove it. Okay, so that was the chain rule. Let's talk about successive differentiation. Sorry, I'm writing roughly. I'm becoming tired. That's the reason. Let's talk about successive differentiation. Okay, so with successive differentiation, I told you it's differentiating it the second time or the third time. So I have a function. I've differentiated it for the first time. I'll differentiate it for the second time. And I'll differentiate it like for the third time, like over and over and over again. So that's what is termed as successive differentiation. So at this point, I'm just going to solve one question or two, right? Under successive differentiation, then we'll bring our studies to a close. Okay, so let's solve one question. Assuming I have a function, right? I want to bring a question in the book, right? But before I even bring a question in the book, let's solve this one. Find if y is equal to 8x cubed plus 4x minus 3, right? Find the square y on the x, sorry. So this is successive differentiation. So at this point C, I have y equal to 8x plus 4x minus 3. Before I can get the square y on the x square, I need to first find the y on the x. So I'm differentiating twice. That will help me arrive at the square y over the x squared. So that is what is termed as successive differentiation. So if I should solve this one, I will say that the y on the x, right, should be equal to what? I'll differentiate this and I'm going to get 24x squared, right, plus 4, right. Yes. So 3/8 is 24. Then I'll subtract 1 from the cube, making square. And this one, if I should differentiate, I'm going to get 4. The negative 1, the 3 is 0. So I'll just leave it down as aside. Sorry. So at this point, right, finding the square y on the x becomes very simple. And that one, I want to differentiate the y dx again. So this one, 24 times 2 will give me 48, right? 48x, and this gives me 0. So in that case, the square y, the s square of this function is giving us 48x. So that is what is termed as successive differentiation. Okay. So let's move on to another question. If I have, let me write this question. If f of x equal to what? 2x exponent 5 minus 4x cubed plus 3x minus 5. Find f prime prime of x. So we are going to find f prime prime of x. So solution. We first need to find f prime of x. That's the first differentiation, right? And this is going to give us what? 10x4, right? Minus 12x squared, right? Plus 3. You get it? So we differentiate it and get this result. Then if we differentiate it again, that will give us the f prime prime of x. And this one is going to be what? 40x cubed, right? Minus 12 times 2 is 24x. So that's going to be the final answer. Okay, let me verify and see. 2 times 5 is 10. First differentiation. Then x 5 minus 1 is giving us 4, right? Then minus 4 times 3 is 12. 2, right, plus 3. The first one is correct. They are differentiating this. 10 times 4 is 40 x cubed minus what? 2 times 12 is 24x. Second one is correct. So this is the final answer. That is the f prime prime of x. So let's solve another question. So let's say if, right, y equal to what? Cos x minus sine x, right? We should evaluate, right? Or we should find. Okay, so we should evaluate in range 0 less or equal to x less or equal to pi on 2, right? When the square y on the x squared is equal to what? Is 0, right? Let me write it in statement. That's how the question was stated. Is 0, right? So let's solve this. So solution. So with this solution, right, we have y equal to what? Cos x minus sine x. So first of all, we need to find the square y on the x squared. So before we can find the square y on the x squared, we need to first find the y on the x. So what is the y on the x? We differentiate this one, we are going to get what? Negative sine x, right? Minus, differentiate this, we are going to get what? Cos x. Okay. So this is the same as negative sine x minus cos x. So that's the value for the y on the x. So we need to find the y or the square y or what on the x squared. And with this, what do we get? The first one is sine x. Sine x will basically give us what? Cos x, right? And sine or cos x is going to give us negative sine x, right? So at the end, you are going to get minus cos x plus sine x. Okay, so the y on the square y on the x square equals what? Sine x minus cos x. So he's saying that the square y on what? On the x square is 0. Okay, so we are going to equate these two equations. So I have equation 1 and equation 2. You get it? Equating the two of them, what do I get? I'm going to get sine x minus cos x equals 0. You get it? So I can still simplify. So I can say that sine x equal to what? Cos x, right? Let me divide both sides by, how do you call it? Let me divide both sides by what? By cos x. So that I want to derive tan x from this one. Because I know that this is sine x, cos x. So I can divide both sides by cos x. So that I will be able to get what? Sine x cos x. Right. So let's divide both sides by cos x. So I'll get sine x over what? Over cos x equal to what? Cos x on what? On cos x. So this cancels this one. Right. So once we cancel both of them, what do we get? We are going to get sin x on cos x equal to what? 0. So at this point, it's the same as what? Tan x equal to 1. Sorry, not 0. Right. If I should divide all of them, I'm going to get 1. So it's not 0. Right. It is 1. You get it. So tan x on cos x should be equal to what? Tan x should be equal to 1. Okay. So once we get that, what will be x here? X will be equal to what? Tan inverse of 1. If it is degree, then it's going to be 45. Okay. So x is going to be 45 degrees, or pi on 4. Yes. So pi on 4 is the radian form. If I have, how do you call it? 45 degrees, then the radian is going to be pi on 4. So it's the same thing. Do you get it? Let me test this. So I'm setting my calculator to, how do you call it? Degree, radian. So 4 tan inverse of, you can try it alongside. Okay, with tan inverse of 1. Yes, I'm right. So that's the final answer. Okay, so the square y on the x square will be given as pi x on 4 in the range right. X pi x on 4 in the range x. 0 is less or equal to x, is less or equal to what? Pi on 2. So you can see that the value that we had was found in the range of x. Do you get it? Yes. So that's the final answer for that question. I want to solve another question, which is very, very, very important. Okay. So it's a proof. I got the proof in the book. So if I should solve that question, then I think I'll bring the tutorials to a close. Or probably I'll have a last question. And once I get that question, I'll bring the tutorials to a close. Okay. So let's solve the question. He says that prove that right, the square y on the x squared plus 6 the y on the x right plus 9y equal to 0 when y is equal to what? 2e, or when y, let me write the continuation here so that I'll get more space. So when y is equal to what? 2x e exponent minus 3x. Yes. So they say that I should prove that this expression is equal to 0. I should prove that this expression or this side is equal to 0, right? So the square y on the x square plus 6 dy over the x plus 9y is equal to 0. That's what I should prove. And they've given me y equal to 2x e minus 3x, right? Okay, so with this one, the first thing that I need to do is to find the differentiation of all of them. So if I have y is equal to what? 2x e exponent what? 3x. 2x exponent negative 3x. That's the y value. So if I want to find the y on the x, please take notes. This is a product rule. Okay. So this is how you do it. You first hold the 2 of x. So we hold the first one and differentiate the second one. So this is some of the things. That's the reason why I was telling you that you should have it in mind so you don't pass through that process. You see, this is a product rule. It's not advisable to go and pass through that long process, but have it in mind and quickly write the answer down, because it is a product rule in the question. So once you do the product rule steps over here, you are going to waste time. So it's better to have the product rule in mind so that when you are solving this question, you're not going to pass through those product rule formula. Are you okay? So at this point, I know that with product rule, I hold the first one and differentiate the second one. So if I should differentiate this, what do I get? I should differentiate the second one. I'm going to get minus 3e minus 3x, right? So I hold this one and differentiate this. Plus, I differentiate this. I differentiate the 2x, right? Or I hold the e exponent negative 3s. We get it. So I hold it. The ones I'm holding, I'm using blue ink. So I hold the second one, which is e minus 3x. And I'll differentiate the first one, which is giving us what? It's giving us 2. If I should differentiate it, it's giving us 2. Okay. So I hold the first one, and I'll differentiate the second one in the first step. Then I'll come and hold or plus. I'll come and hold the second one and differentiate the first one. Okay, first expression. So now that we've been able to differentiate it like this, we can simplify. Okay, simplifying it, what do we get? I'm going to get negative 6x, right? This gives me negative 6x. E minus 3x. Okay, so 2 times 3 is negative 6x. And e minus 3x, right? Plus, what do I get here? 2e minus 3x. So that is the final answer for dy on the x. So what about the square y on the x square? Let me write it far away because I'm going to use the wider side of the board. So now I'm going to find the square y on what? On the x square. Right. So you see, this is differentiation by product rule, and this is normal differentiation. If we say we should find the square y over the x square, we need to differentiate the dy over the x to get the square y over the x square. That's what is called the successive differentiation. Okay. So at this point, I need to differentiate this one, and this is the product rule. Product rule. Okay. So we are going to apply product rule in solving the first one. Then this is just a normal differentiation. So let's continue. If I'm considering the first one, I hold the negative 6x. So I'll hold the negative 6x, negative 6x, right? And then I'll differentiate the e minus 3x. So I'm going to differentiate that one. How do I get? I'm going to get minus 3e minus 3x. Are you okay? Yes. So plus. Let's move on. So at this time, you are going to hold this one. You are going to hold the e minus 3x. And we differentiate the negative what? 6x. So let's differentiate the negative 6x. If you should differentiate negative 6x, what do we get? We are going to get minus 6. Okay. Yes. So that is the differentiation for the bigger expression there. This one. Okay. So now that we've been able to achieve this one, then we need to just differentiate the second one too. The second term. Yes. So what will the second term be? It's going to be plus minus 6. Negative 3 times 2 is going to be minus 6. E minus 3x. Are you okay? Yes. So that is the final differentiation for the second term. So now we can simplify. So once you are done with the differentiation, simplification becomes easy. So we have negative 6 times negative 3 is going to give us 18. So 18x e negative 3x. Perfect. Right. And this is going to give us minus 6e minus 3x. Right. And this whole thing will be minus 6e minus 3x. Okay. You can simplify something else. Right. So this one and this one are the same. So we can write it as 18x e minus 3x minus what? 12e minus 3x. Yes. Now that we've been able to get all the differentiation, the question was saying that we should prove that the square y on the x square plus 6 dy dx plus 9y should be equal to 0. That is, it was saying that we should prove that the square y on the x square plus 6 dy on the x plus 9y should be equal to 0. I think I'm on the right path. Yes, I've been able to write the expression very well. So now we substitute. What is the square y on the x square? It was giving us 18x e minus 3x minus 12e minus 3x. So that was for the square y over the x plus 6 the y on the x is giving us this expression. Right. We can remove the brackets, the two brackets. And once we remove the two brackets, it will be clearer to write it. So, we can remove this bracket like this. Yes. We are going to get minus 6. Let me do the minus 6x, right? Minus 6x e minus 3x. Hope I'm right. Yes, we have minus 6x e minus 3x plus 2e plus 2e minus 3x. Right. Yes, that's the same expression there. You get it. Then plus 9y. So plus 9 into bracket. What is y? Y was originally giving us 2x e minus 3x. Right. So we write the y there, which is giving us 2x e minus 3x. right? And this is equal to what? 0. So now let's express this one. Let's simplify this. So simplifying this, you are going to get the 18x e minus 3x minus 12 e minus 3x, right? This will give us minus 6 times 6 is 12, right? 12, sorry. So 6 times 6 is 36. Sorry, I made a mistake. 6 times 6 is 36. So minus 36 x, right? E minus 3x. Do you get it? Then 6 times 2 is 12. So plus 12 e minus 3x plus 9 times 2 is 18. 18x e minus 3x equal to 0. So what do we have? You see that this 18 and this 18, they are the same term, right? So I can add them. If I should add them, what do I get? 18 plus 18 is 36. That is, if I have 18 plus 18, 8 plus 8 is 16. 6 remainder 1, you get 36. Okay. So we have 36 x e minus 3x. So we have, it all have x. So 18 plus 8, these two expressions give me 36 x e minus 6x. Very good. Now I have minus what? 12 e minus 3x. Right. Very good. Then the next one will be plus. I've written this and this as one term. I'm just repeating the rest. So I have this one. Then I can write this minus 36 x e minus 3x, right? Then plus, that's the last one, 12 e minus 3x, right, is equal to 0. So here we can see something clearly here. Negative 1 plus 1 is equal to 0, right? So the negative, if I have negative 36 plus 36, this term are the same. What I'm trying to say is that this term are the same. One is positive, one is negative, so it can cancel out. This term and this term too are also the same, so they can cancel out. So at the end, I'm going to get 0 is equal to 0, right? So therefore, since 0 is equal to 0, we can clearly say that the square y on what? On the x square plus 6 dy on the x, right, plus 9y is equal to 0 when y is equal to what? 2x e minus 3x. Yes, so that is it. So that is going to be the final answer. We've been able to prove it. So if you don't understand, please watch the video again. Okay, and you'll be able to prove it very well. Calculus is one of the most interesting courses, but sometimes you need to take your time in solving it. Once you don't take your time, you end up making mistakes, right? And nobody wants to end up getting mistakes. So anytime you have the question, just take your time and do what? And analyze it. So once you analyze it and you get your results, then you are good to go. I'm going to leave you with one tough question, summarizing like almost everything that you've done. Not almost everything. I'm going to solve one more question and I'll bring it to a close. That is y equal to what? T e squared t, right? All divided by 2 cos t. So the question says that we should differentiate this. Find dy over dx of y equal to te 2 square over cos 2t. The question is really complicated. You see, we have product rule on top and we have the quotient rule in general. Okay, so if I should solve this one, it's going to be quite complicated. You get it? It's complicated. But let's solve it. Solution. The video might be long, but let's solve this one and we'll bring it to a close. Right. So, y is equal to what? T e squared t on what? On 2 cos t. We are going to let, if you let what? Y be equal to what? U of x all divided by what? V of x. We get it. So in that case, the u of x is equal to what? T e 2t. We get it. So if I should find the u on the x, what do? I hold the first one. But that don't show them, don't show it. Just use your mind to simplify it and you go your way. I hold the first one, which is t, and I differentiate the second one. If I should differentiate it, what do I get? I'm going to get 2e 2t, right? Plus, I hold the second one, e 2t, and differentiate the first one, which will give me 1. You get it? If I differentiate t, I'm going to get 1. So at the long run, I'm going to get 2, right, t e 2t plus what? Plus e 2t. Let's put it aside and move on. Then what will be v? V is going to be what? V of x will be giving us 2 cos t. What is the v on the x? The v on the x is giving us what? Is giving us 2 negative 2 sine t. Right? Yes. So again, if you are struggling, just watch my video and you'll be fine. My previous videos. So now that we've been able to do this, that's where the tax is. So now that we've been able to do this, then we are going to get the formula. That is the y on the x is equal to what? V of x. Then we differentiate the u. That is the u on the x minus, we hold the u of x. Then we differentiate the v on the x. All on what? On v x all squared. So that's the general formula. So once we get it, we just substitute. So we just substitute the values there. So when we are substituting, what do we get? We are going to get, what is the v? The v of x was given us 2 cos t. Cos t, right? Then the du on the x is giving us, the u on the x is giving us what? It's giving us 2t e 2t plus e 2t. Okay, very good. Then minus, what is u? U of x. U of x was giving us what? Was giving us t e 2t. Right. So then what is, how do you call it? The dv on the x. It was also giving us, so we are going to multiply that one minus 2 sine t. Right. Yes. So you are multiplying it with it. Very good. So at the end, what is v? V is giving, vx was giving us 2 cos t. So 2 cos t all squared. You get it? Yeah, it's quite complicated. So that's the reason why you always need to take your time when you are solving questions like this, else you are going to struggle. So let's move on. At this point, what can we do? We can simplify, and that will be the result. That's the y on the x. If I was supposed to be in class, I'll ask you to simplify and show it to me, but since I'm not in class, you let me continue to simplify this. Are you okay? So how do you do the simplification? This side, I can see that the common term here is what? Is e hot 2t and e 2t for this one. So I can bring it out and I'll multiply it with the 2 cos t. So at the end, what do I get? I'm going to get 2 et. Let me bring the et first. 2, right, e 2t, right, cos t. So I've brought the 2et out. I've multiplied with the 2 cos t, right. Then what will be left inside? It will be left with 2t plus what? Plus e 2t plus 1, sorry. So 2t plus what? Plus 1, because I've taken the e 2t out. Okay. And here too, negative is going to be plus. So we have our plus. Then we have t, or let's bring the 2 out first. We are simplifying this one. Negative becomes positive. Then we have a number there. So 2 comes out. Then we have t e 2t, right? So t e 2t. Then we have our sine t there, which is sine t, right? All divided by what? 2 cos t all squared, right? Yes, so that was the value for the vein. So the vein was 2 cos t. We get it. So here we can still do further simplification. What's the further simplification? We have 2e 2t cos t 2t what plus 1 at the first term, all divided by what? 4 cos 2t. If I should expand it, I'm going to get 4 cos 2t. Or 4 cos square, not 2t, but it's cos square t. Sorry. So this cos square t, right? Plus 2t e 2t sine t, all on what? On 4 cos square t, right? So here 2 cancels 2 here, then we have 2 at this side, 2 cancel itself, and we have 2 at this side, right? So we can say that is equivalent to what? e2t cos t, or into bracket 2t plus 1 for the first term, and that gives us 2 cos square t, right, plus t e 2t sine t, all divided by what? Cos square t. You can choose to end here, but if you should simplify, you can simplify and simplify and simplify and simplify. Because I'm still seeing some simplification here. You see that if we have this cos t, right, can cancel one of the causes, and this one too, we can get tan t. So at the end, if I should simplify, I can simplify and simplify, right? But you can end here. I'm going to get, let's say, e 2t multiplied by what? 2t plus 1, right? All divided by what? 2 cos t, right? Multiply by this one, I'm going to get t e 2t times sine t cos t, give us tan t, right? Tan t multiplied by 1 over what? Cos t. I just took one of the cos t, right? This is the same as, this side is the same as cos t, and I related the sine t here and the cos t here to be as tan. You get it? So when we have 1 cos t here, I even forgot to bring the 2, right? So 2 cos t. So at the end, if I should further simplify, we have a common term. We have we have, how do you call it? I hope I'm not even confusing myself because it's so long, right? At the end, how do you call it? I have the 2t here. We have this term here, right? This is common to this. This is common to this. Do you get it? So this is the plus. So we have this one and this, they are common. And we have 2t, they are common. Do you get it? So I can factorize them out. And I'm going to get, let me write it down. So I'm going to get e2t, right, on 2 cos t. So how do I have here? I'm going to get 2t plus 1, right, plus t e 2t tan t. Oh, sorry, I don't need to bring the, how do you call this, the e2t again. So I'll take this one off, right, going to be plus t tan t. Do you get it? So if you simplify and simplify and simplify and simplify. I believe this one today can be still simplification. But if you're able to end here, you are good to go. My target is to show you the differentiation. But if you should simplify, you can simplify and simplify and simplify and move on. It has made the video so long. Thank you for watching. Right. If you have any question under what I've solved, or if you see any error in it, please remind me, Ayeki, and I'll correct it. But watch it very well before, like, you make comments. They get it. And I'll be so happy to receive any criticisms. Ayeki, thank you. I wish you all the best. The video has become, I believe this is going to be the longest video that I've ever made. So, and I've ended here. The next one I'm going to talk about the implicit function, something of that sort. So please, all the best, and wishing you the best of luck this semester. I believe that with this one, right, with this one, you can, when you start class the first week, you'll be able to understand what is going on in the classroom. Please, don't forget to subscribe to my channel, right? And we are almost done with the differentiation. We are almost done. And I'm so glad that we are almost done with the differentiation. Then we'll move to integration. Then we'll move on. So by the close of the semester, I've covered everything. And you get the confidence to write your exams. Wishing you the best of luck. Bye bye. See you another time.